Alright, so I know that might be hard for you guys to see, but it's not super important, so I'll just go over some of the main specs of y'all's tablet. It is a fully functioning computer that runs on Windows 10 Professional. It's got Gorilla Glass screen, which is ridiculously tough on its own. Then you throw that screen protector on there, it's almost indestructible. 128 gigs of internal storage with 8 gigs of RAM. Operating temperatures are negative 22 degrees Fahrenheit to plus 130. Had it in Texas summer heat, 110 degrees with 100% humidity, 1,000 times over, no issues at all. So generally speaking, I wouldn't worry about the operating temperatures. It's got an IP rating of 65, which has to do with water and dust. It is pretty damn waterproof in regards to how you'll be using it. So if you guys get stuck in the rain or snow, I would not worry about that. I'd go to this thing right here.
And it's like 36 hours out on a beach, right? 65?
I do believe so. Or like 3 feet for 30 minutes or something like that before your water starts seeping into the ports. Yeah, so if you do get stuck in the rain or snow, if it's a light shower or drizzle or what you consider, it's sprinkling or something, I'd probably just keep on trucking. It's not waterproof. I definitely would say it's a little bit water resistant. So if it's a downpour or something, or if it's one of them deals where it's heavy rain, you check your radar, it's going to pass in 30 minutes to an hour. So there's that white bag in there. I don't know if you guys seen it. We call that the Trimble shower cap. Throw that sucker over there and just cinch it down if you don't want to break setup. You cannot lay out with that bag on there, but like I said, if it's something you know is going to pass, that'd be a good way to just cover it without having to break your setup. If it does get wet, I highly recommend that you guys either put it in the case with the lid open or out on a table or gang box somewhere where it can air dry, because this case has a waterproof seal around it, and if water gets inside those optics, it's going to be a mess, and you'll have to call Trimble, probably get a loaner sent to you, because you're going to have to send it back to us so they can fix it and all that stuff. So yeah, just do your best not to let it get soaked. A little sprinkle's cool.
How about like dust? Because on a job site there's...
So that's a question I get asked a lot, or that, and is there any routine maintenance we can perform on our robot? It's yes, but very minimal. So if you're on a dusty site, the only couple things I could recommend, right in here where those bearings are, maybe get a can of air with that straw, and blow that out every now and then. And if it gets dirty, maybe hit this with a dry toothbrush and a can of air or something like that. Other than that,
the things that move, I guess.
Yeah. Other than that, you shouldn't have to worry about anything.
Okay.
And that's the main stuff on the tablet there. It is Bluetooth and Wi-Fi capable as well.
Nice.
So, MagDrive servo system. I'll give y'all a demo of that while I'm talking about it. So there is no gears inside of this robot that turn it to drive it when you're walking around laying out points and it's following you, which allows for quieter operation, faster operation, and in regards to precision and accuracy, of course we don't have time, but if we were able to set this to its slowest setting, it would take over a month to make one full rotation.
Wow.
Yeah, so how it's driven is a series of alternating pole magnets, positive and negative, pushing up against each other. That's the demo of the MagDrive servo system. As you can almost not hear, it's pretty damn quiet. So one of the many common misconceptions about this robot, and there's a whole bucket full, and I'll do my best to cover them as we go. But most field guys that use this, they know and understand, it's a $40,000, $50,000 robot, and they're scared to touch it. Oh, is it delicate? I don't want to put my hands on it. But with no gears being inside of there, if you need to manually turn that sucker to do whatever you're doing, it's not going to hurt anything. It'll just keep on going.
What's it doing right? Is it like got a pre-programmed to do what it's doing?
Yeah, it's just a demo to...
Oh, demo pro, okay.
Yeah, for the MagDrive servo system. Another common misconception that I always think of when I show this slide here is that it's a GPS, works off satellites. 100% incorrect. So this is what we call a line of sight instrument. As long as you can see it, you can lay it out. So, we stress that you need at least 2 control points or 2 reference points, whatever you want to call it, to get going. Example, let's say we set the robot up here. We shoot 1 control point over there, 1 control point over there. Once we do that and our instrument location has been established, we're not limited to just lay out in that slice of pie. You know what I'm saying?
Right.
Once you do that, your robot knows where it's at in your model.
Okay. That's
360 degree field of view. Like I said, as long as you can see it, you can lay it out.
You need 2 points, I guess, don't you?
Yeah, and you can shoot up to 5.
Mm-hmm.
So we'll dive in.
Oh, to give you a more precise location.
Yeah, and see, well, like I said, we'll get into it more as we go, but every chance I get, I shoot at least 3.
Mm-hmm.
Makes things a lot easier on you. On the vertical, not quite 360, still a wide range. Coming up this way, as you guys can see, we have this offset handle. So if you're doing any laser work or maybe either laying something out on the ceiling or just spot checking something with the laser,
Mm-hmm.
you can do that with this offset handle. Coming down this way, you got about, I don't know, 150 degree field of view before you start cutting into the base here. So if you're ever laying out and catch maybe in a deep hole or a deep trench, something like that,
Mm-hmm.
if you catch yourself cutting into the base of that, that'd be your red flag to move your robot around to get to a better location where you can see what you're doing. Distance and angle measurement. So when you hit the first thing that happens when you hit that shoot button on that tablet, the robot sends an EDM signal that hits the center of the glass in that prism right there, bounces back and forth, calculating the slope distance. Once that calculation is made, it then calculates the second leg of the triangle, which is the vertical distance. Now, one of the very few things that the robot cannot do is determine whether or not you can get the most accurate shot possible. So after the second leg of the triangle is calculated, it then goes for that third leg, which is the horizontal distance, and that is what's going to be displayed on your tablet screen as forward, back, left, and right as you're walking to lay that point out. You guys feel free to stop me, or if you have any questions, or if I need to back up a slide, I got no problem.
Is there any way of holding that thing so that it's like, it like kind of like hangs plumb, so you don't have to keep like putting it down and then plumb it up, and you got to move it over a little bit?
No, sir. It's just getting there, plumbing
guess-
up, shooting.
I guess it's a matter of getting used to it.
Yeah, definitely. It'll become second nature.
Okay.
After a month or so, you guys will be pretty damn good at it. I could almost guarantee you. So the target ID tracking. There is well, first let me go over this. The red line right there represents that triangulation calculation going on in the background. And this green arrow represents the radio signal being broadcasted from the radio right here that communicates with the robot to help the robot identify the target, stay locked onto the target, and not be disrupted by false targets. The other big reason why we came out with this prism with the radio in it is for situations like this. I don't know if you guys can see it very good, but we got 1, 2, 3, 4, and we were robot number 5 coming onto this small deck. So if you ever catch yourself in a situation where you have more than one Trimble robot in your general area, it'd be wise for you to just make your rounds and figure out what channel they're on here and just be on a different channel. So a couple
many
little side
channels are
notes.
there?
There's 8 to choose from.
Okay.
So let's say you guys are both on channel 1. You're on level 1. You're on the north side over here. You're working on the south side. Not going to be an issue. Let's see. Okay, channel 1, both of y'all. You're on level 1. You're on level 2. Not going to be an issue. But the only time it could be an issue is if more than one Trimble robot is in the same general area crossing paths, because then your robot could lock onto his prism, vice versa, and it could be a mess.
So that guy right here on this pole wouldn't be affected by the one that's to the right of the blue tarp up there?
None of them. So if all 5 of those instruments are on different channels, man, you could be crisscrossing all day long and no issues.
Okay.
Another thing, if you have another robot. So yesterday I was in where the hell was I? Man, I travel so much I can never remember where I'm at. Anyways, there was a Sokia robot and 2 Leica robots. So first thing those guys asked is, man, is that going to mess with our prisms? Not at all. Now, if those guys, if they don't have a radio on their prism and you cross paths with them, their robot could lock onto your prism, but that is not going to affect anything that you're doing. And as a matter of fact, we were taking care of business, laying out some points yesterday, and one of the guys in the class, he was about, 30, 40 foot away from one of these Sokia robots out there, and their robot caught onto on their prism and it started following. That dude came over here He's like, are y'all controlling my robot? I was like, no, man, you just don't have a radio on your Prism.
Mm. Wow.
All right, so first thing I always like to mention about this slide, I am not the one responsible for making this goofy ass slide here, but it sticks with people, so I just roll with it. So shooting in control points. If you're just shooting 2, this is what I call the triangle rule. Now, like I said, every chance I get, I would say 9 times out of 10, if I've got more than 2 to shoot, I'm going for it. But we'll talk about just shooting 2 for a second. So ideally, whenever you're out on the job site trying to figure out where to position your robot, and you identify 2 columns you want to, or we'll say 2 points you want to shoot, ideally, again, you're trying to set your robot up with these 2 points in the shape of an equilateral triangle or right triangle. Now, okay, let's say when you shoot that first point and then walk to that second one, your robot needs to swing a minimum of 45 degrees, but not to exceed 135. If that second shot is less than 45 or greater than 135, like that triangle there, you'll get an orange pop-up on the bottom of your tablet screen that says unreliable, unable to calculate station location. Station location being where your robot is located. So naturally, what will help you get get closest to that equilateral or right triangle, if these points, let's say they're 50 foot apart, with just shooting 2, that would tell you need to have that robot about 50 foot away from there to achieve that good looking triangle. Now, one of the cool things about shooting more than 2 control points, when you shoot 3, 4, or like I said, you can shoot up to 5, you don't necessarily eliminate the triangle rule. You're just adding more triangles for the software to figure out where your robot's located. A couple benefits of shooting more than 2, it's a lot easier on you, because when you're shooting 2, you're going to catch yourself doing this here. I think I want my robot here. I got a control point over there and one over there. I don't know, it's a little tight. What about, doing this here, checking, eyeballing angles can be frustrating and pain in the ass, to be honest. So just adding a third one eliminates that, you know what I'm saying? Because you no longer need to have that triangle rule pounded in your head. And it's just, the other benefit is it drastically increases the spots where you can set that robot up. With 2, you're pretty limited, I'm sure you can imagine, with trying to achieve that triangle, So like I said, every chance I get, I'd shoot more than 2. And we'll go over that a lot more as we go, so no worries there. A port control setup example, as you guys can see, we got 1, 2, 3, 4 control points on that in that area. And again, that's not going to work because that's far less than 45. So a couple things this guy could have done is shot a third one, or hell, shot all 4 of them, and that probably would have been good enough to get him going. Another port control setup example, and again, you can easily see that's not going to work because that is far greater than 135 degrees. So a couple things he could have done in this situation: could have moved his robot down this way to get that right triangle look, or again, could have shot 3 or all 4 of them. And he moves his robot.
There we go.
And there we go. So, acceptable working radius. This is probably one of the most important concepts and just general ideas that you need to learn and implement into your layout and when you take this to the field. So, back in the day, I'll say, before we had this fancy new layout software we got, like growing up as a land surveyor, well, I wasn't a land surveyor my entire career. I did that for about 3 or 4 years, but back then it was always, hey, whenever you're shooting your control points, always shoot the farthest one first. That way your robot and software knows to use that to build your acceptable working radius. Not the case anymore. So it never matters what control point you shoot first, whether it's the farthest, the closest, one kind of in the middle out of the 3 or 4 you're going to shoot or whatever. Software knows to use the farthest one to build that acceptable working radius. So how this works, again, we're just going to use the 2-point resection as an example. Now, resection, if anybody doesn't know what that is, that's A resection setup is where you set your robot up anywhere and shoot 2 to 5 known points to establish your location. So again, let's say those are about, I don't know, 100 foot apart. That would tell you you need to have that robot about 100 feet away from those. Now, let me make up a little scenario. Let's say this point is about 100 foot from the robot, and that one's about, I don't know, 85. So when we shoot those 2 points, the software knows to use that to build that radius. Now, how this works, let's say we shoot those 2 control points, and down here at the bottom of our tablet screen it says instrument position within 16th. So that's damn near a perfect setup. A perfect setup would be instrument position within 0. So let's say we got a 16th. We know our farthest shot was about 100 foot. Now, a little side note real quick before I continue. There's no need to bust out some 100, 200 foot tape, start measuring between. A good eyeballs guess on that is good enough. So shot those 2, overall setup error was a 1/16 of an inch. We know that was 100 foot, so that tells us within that 100 foot radius around our robot, every point we lay out is going to maintain a 1/16 of an inch accuracy. Now, best practice would be always try to lay out within your acceptable working radius. Now, a little contradicting statement right after that one would be, at times it's totally okay to lay out points outside of your radius. A couple things you need to factor in and think of before you do so. You got to know, well, first off, if you lay out a point that's past that farthest control point, whether it's an inch or 2 or 500 feet, you'll get an orange pop-up window at the bottom of your screen. I don't remember exactly how it's worded, but it says something like you're trying to lay out a point that's farther than your farthest control point used in your setup. If you see that, that's like the software saying, hey, check yourself. What was your initial error, and how far past that point are you? Because another thing you need to keep in mind, when you double your distance from the robot, you double your error. So if we were at 100 foot here, overall error was a 1/16. If we double that and go to 200 foot, every point in that radius is going to maintain an 1/8 of an inch accuracy. Double it again, 300 foot, everything in that's going to maintain a 1/4 inch. So even at a 1/4 inch, damn near anything that you guys lay out on, we'll say the MEP side of construction is going to be well good enough within a 1/4 inch, you know. But again, that's always different from company to company. But that's just what you need to keep in mind. So let's say you did get almost a perfect setup and had a 1/16, and now you're out here at 200 foot. Keep in mind, every shot you take that's past that point, you'll get that orange pop-up window, and that does kind of suck, but I mean, just close it out. If you've already verified and checked with yourself, you know, okay, I'm good, I've had a perfect setup damn near, so I ain't worried about that, then just keep on keeping on. Everybody good with that? Cool. So the direct reflex laser, or the DR laser, really awesome tool. It allows you to take measurements and shoot stuff or lay stuff out that you can't physically get with your prism pole. Now, although it is a really awesome part of this and feature of this robot, keep in mind that it is not the best application for everything. So I would say and recommend that the best application for that is always going to be inside the building, you know, when you always have the shade of the floor above you. Couple of scenarios that would not be best to use the laser would be dirt work, you know, undergrounds or anything like that. And the other one I would not recommend trying the laser out with is corrugated steel decks, just because it's so damn shiny. You know, that laser, it kind of freaks it out, and a lot of times won't even be able to measure because it's so shiny. Why I think that is because, not 100%, but I think it's just such a reflective surface, you know, that corrugated deck, that it kind of messes with that EDM signal, which is electronic distance measuring. I don't remember if I mentioned that, but like I said, awesome tool, and we'll cover all that stuff maybe today since we're going to be at a job site. The SurePoint technology, that is the auto compensator inside of the robot that helps keep it level for slight movements, you know, such as foot traffic, machinery driving around the robot, stuff like that. The key word there, though, was slight movement. So one of the biggest things I always like to throw out there when talking about this is that anytime you need to move your robot, I highly recommend you turn it off. Now, you can either hold the power button down for a second, or what I have gotten the habit of doing anytime I want to kill it, open the battery door. That will not hurt it at all whatsoever. And the main reason I say that because if you were to take that off the base of your tripod and walk to your next setup, I wouldn't say that would 100% damage or destroy anything in your robot. But this movement here of you walking with it is a lot more, is outside of the parameters in which it was designed to work for, you know what I'm saying? So always shut it down before you move in, you'll have no issues. Alright, so the specs, you guys have this one right here, the 773. The distance you can look to achieve with your, or when in prism mode, is 2,100 feet. Now, I cannot personally attest to taking shots that far away, but what I can personally attest to, which is still pretty crazy in regards to just the distance away from your robot, some years back, there's quite a few jobs I was on actually that were big warehouse jobs, and I'm talking like 1 million, 2 million square foot warehouse jobs. And during the underground, there's oftentimes, or a lot of times, where I was set up on one of the corners, and I would be taking, you know, laying out points 1,000 to 1,500 foot away from my robot and had no issues. So, like I said, generally speaking, even 1,000 foot's way further than the average MEP guy is going to be working. So, generally speaking, I wouldn't worry about distance. With the laser, you're looking at 490 feet. Now, that's where things get a little hairy. So, when you're using the laser work, or using the laser to lay out, if you're within 20 to 50 foot or so, 60 foot, I mean, you'll see a definitive red dot on the ground. You go to 100 foot or so, that dot starts
getting bigger,
growing, you know what I'm saying? So at 490 feet, I personally have never laid out that far, nor have I known anybody with the laser, so keep that in mind. I mean, my biggest deal, first off, for laying out, I'm not a big fan of the laser, not downplaying it all, but a couple reasons why is for the majority of my career, I've been on a lot of big 20, 30 story hospitals, stuff like that. So I'm sure you can imagine, you know, if you got 700 to 1,000 plus men on a site, the amount of traffic on every floor is just unreal. And for me, it always felt like every time I would try it, as soon as that laser hit the ground, I start trying to measure, I'd have a scissor lift driving by, or 10, 12 guys walking in front of me or something. But again, just generally speaking, I think you're going to be way faster with the prism pole. I would say so fast, of course, once you guys get comfortable and stuff, but so fast that I would say you can't even compare the speed of laying out with the prism pole to laying out with that. But again, I just tell folks, know your installation, you know what I'm saying, to figure out what might be a better application for you, whether it's the laser or the prism pole. Accuracy, either way you go, you're looking at about a 1/16 of an inch. I wouldn't expect to be able to lay out anything tighter than that, but again, in the MEP world, 1/16 of an inch is overkill in a lot of situations. You guys have Trimble Vision, which is this camera right here. So if you turn that on, there's a few different ways you can use that. But when you turn that camera on, it just lets you see a live view from the robot's perspective.
Nice.
The laser is Class 2 laser. I don't have, just being honest with you guys, don't have a lot of information about the class. I do know that has something to do with how it can damage your eyes and stuff.
That's what I was wondering about, yeah.
Yeah, so Trimble considers these an eye-safe, eye-blink laser. Again, that's one of the only little tidbits of info I don't have about it. But in layman's terms, I will say that if that laser crosses your eyes, it's going to feel like your fucking retinas were melted. It's not that bad, though. I mean, have any of you ever experienced flash burn from welding or somebody welding? Nothing like that. Nothing at all. I mean, it's a quick, like, oh shit type sting, and then it's done. But just don't look at it. You'll be good. It does have a little power light or power indicator there. You can check that.
How long does that last using the battery?
You can expect to get 6 to 8 hours of use out of one battery that's fully charged first thing in the morning. Yeah. Of course, that's going to vary a little bit depending on how fast you're clicking on that screen, you know, rocking and rolling through the job site. But on average, 6 to 8 hours.
Do we have, how many batteries do we have?
Two, I do believe.
Oh, good.
One of the
Okay.
smaller ones for the prism.
Yeah. And the prism batteries, I don't have any slides on that for some reason, but for the
So
most
maybe-
part, one fully charged prism battery will last you a good 10, 12 hours.
Well, how about, I mean, okay, so you're using it, the battery goes dead. How long does it take to charge the battery again if you don't have a second battery for the Trimble?
I can't answer that, but I do know there's been many times where I've been working or had some of my guys working for me that forgot to charge the batteries at quitting time. show up the next morning with half-ass charged batteries.
Mm-hmm.
And I do know that if, let's say your battery dies before lunch or right around lunchtime, if you let that thing charge up during lunch, you know, a 30-minute lunch, it'll last you the rest of the day when you hit the ground running after lunch. So
is there a way of hooking power up to it, like a 12-volt or whatever adapter or something?
No.
Okay, because the thing's got to turn. I get that.
Yeah.
Okay.
So the charger, the little gray charger I saw in y'all's box, I can show that to you later.
Mm-hmm.
It is now, it does hold both batteries. It is a cycle charger. I cannot tell you guys how many calls, texts, and emails I get on a weekly basis about this damn charger. And I'm sure tech support gets 1,000 more. But what all those calls consist of is, Caleb, dude, we just took our robot out for the first time this week, hit the ground running with it, go to charge our batteries up, and only one's blinking. Something's broke, it only charges one battery, man. What's up? Who do we talk to? That's when I jokefully remind them that it is a cycle charger. So how this charger works, it does not matter whether you plug the left one or right one in first. Whichever one goes in first, it'll juice that one up to 100, jump to the next one, charge that one up to 100. It does have a reconditioning cycle or reconditioning feature on there. If you guys ever get to a point where you realize your battery's not giving you the same amount of life, maybe it's down around the 4 or 5 hour mark or something, I would recommend that before you just straight up buy a new battery, because that can get pricey, I'd recommend doing a reconditioning cycle on it, see if that fixes it. In most cases, with my experience, not everyone, but the few times that I have experienced that where it's just dying a little sooner than it was, like I said, in most cases a reconditioning cycle has fixed it up for me. So same deal with the reconditioning though. Whichever one goes in first, when you hit those reconditioning buttons, it'll drain it to 0, charge it back up to 100, jump over to the next one, do the same. Now if you guys ever get to a point where you feel like you need to do that, don't think you're going to plug it in at lunchtime and hit that reconditioning button and then be good to go after lunch. It'll shut you down the rest of the day. Not sure how long it takes, because the few times I have felt the need to do it, I just did it at quitting time. So I'd recommend the same. Wait till quitting time, do it. You show up the next day, it'll be fine. Or if you can wait till Friday, it won't hurt to leave those batteries in over the weekend, charging or reconditioning. So keep that in mind as well. Horizontal and vertical tolerances. You have the option within your software here to change a couple different tolerance related settings. This would be a representation of laying out a point in a perfect world, we'll say. That cone looking deal representing the tip of your prism pole. And as we know, it's just not humanly possible to lay out a point that accurately. So with that being said is why we've implemented these tolerance related settings into our software. 1/4 inch example, we'll go with that one first. So if you set your tolerance related settings to a 1/4 inch, it puts a 1/4 inch tolerance field around all of your design points. So how that works, as you're walking to that point, as soon as the tip of your prism pole enters that tolerance field, your bullseye is going to light up green, let you know, hey, you're good to go, stake it out here. And you can change that setting all the way from a 1/16 of an inch up to an inch. So how I like to work that, and of course it works the same on whatever setting you have, but how I like to work it is before I shoot my control points. So knowing that when we shoot our control points, that's the most precise thing that you're going to be doing on a daily basis, because you're only as good as the control points in which you shoot, right? So knowing you got to be damn near perfect with that, before I shoot my control points, I'll drop both of my tolerance related settings down to a 1/16 of an inch. Tag however many control points I'm going to shoot. After that, and I've verified my instrument position is good, I'll jump it up to a 1/4, generally speaking. So if I'm doing inside the building work, I'm going to set it to a 1/4. If you're doing dirt work or any, we'll say, rough staking comparable to dirt work, hell, I would set that sucker to a 1/2 inch or maybe an inch. Example I like to go with on the high side of this tolerance setting, if you're doing, let's say, underground, laying out your trenches, if you got a 2 or 3 foot bucket on whatever you're digging with, 1 inch one way or another is not going to matter or throw you off, you know what I'm saying? So for rough staking type stuff, 1/2 inch or an inch, that tolerance related setting is going to allow you to be a lot quicker. That way you won't be in the dirt, you know what I'm saying, stabbing away, trying to drive to that 1/16, 1/8, or a 1/4 inch. And that is it for the slide presentation. So, like I said, we can take a quick little break if you guys want to, and we'll get going whenever y'all get back or whatnot.